Now the next problem is two long parallel wires, they are at a distance of 2D apart. They carry steady equal current flowing out of the plane of the paper as shown. The variation of the magnetic field along the line XX dash is given by. Okay, now let us say this is line XX dash and you have two conducting wires. Current is coming out of the plane of the paper and the currents are equal. Okay, and the distance between them is given as 2D. Okay, so at the midpoint of these two wires you have distance DD on both the sides. Now let us say this is wire 1 and this is wire 2. Now because of the flow of current in wire 1, the magnetic field lines will be like this. Okay, they will be making these kind of loops. Okay, for this also they have these kind of loops with magnetic field going in this direction. Now we are interested only in line XX dash. Okay, so let us say this is wire 1. So for wire 1 and for wire 2, the magnetic field at various points along XX dash will consider in their magnitude separately and in their directions on this axis. So we have three cases. One is this case, beyond point 1 to the left of point 1, beyond point 2 to the right of point 2, and in between 1 and 2. We have three regions. So we will study all the three one by one. Let us begin with the first one, that is in between. Okay, so if in between, if you find out B1 is always above and B2 will be always downwards. So B1, which is given by mu naught I upon 2 pi x. So when this distance x is lesser as compared to this distance x2, then in that case B1 will be more than B2, and B1 will be equal to B2 when x1 and x2 they become equal. Okay, so when x1 is equal to x2, which is equal to D, then the net magnetic field at the center would be 0. Okay, now from this discussion we know that in between the points, at this point you have magnetic field as 0, and at this point you have maximum magnetic field, and it keeps on reducing till this point, and then it again increases. Okay, so in between curve we have got. Now exactly at point 1 and exactly at point 2 you have infinite magnetic field, because the value of x will become equal to 0. Okay, so this is the correct curve. Okay, so this is reaching, or this is tending to infinity. This is also tending to infinity. Okay, now let us consider region beyond point 1 to the left of point 1. Now again for this point 1, if you find out the magnetic field due to 1 will be here, and magnetic field due to 2 will also be downwards. So it is B1 and B2 both acting downwards. So as you move along this distance, you will get a reduction in the magnetic field strength, because the distance from 1 as well as 2 is reducing. Okay, so you will get this kind of curve. Okay, and at infinity it becomes 0. Okay, now for this point, beyond this point 2 to the right of it, okay, now the magnetic field due to 2 is also up, and magnetic field due to 1 is also up. Now B1 and B2 they will always add up at any point beyond point 2. Okay, and the curve would be something like this. At infinity it will again become 0. So if you consolidate all the three, 1, 2 and 3, the curve is something like this. In between it is like this. Okay, and then beyond 2 it is like this, and beyond 1 it is like this. So option A is correct. At midpoint it is 0, and at this point it is infinity, at this point it is minus infinity, becoming infinity the moment you move beyond point 2, and this it becomes minus infinity if you move beyond point 1 in this direction. Okay,